Hello, good afternoon, everybody. So today I'll take a class on differential equation. And as you know, we did in today's class in our classroom, linear differential equation, and we did a few of the examples, right? So now I'm going to do the remaining questions, which I think I can finish it in our class today. So I plan to, take the class online when all of you are available. But since you are not available, all of you are not available, so I have recorded this session so that you can later on see and try to understand and clarify your doubts during my class time. So let us begin with the class. Sorry. Okay. So linear partial differential equation. So let us see one particular problem. Question number 10. Question number 10, which was, it was actually very interesting question. You see here, you need to find the GS. Okay. What is GS? General solution, right? General solution of this one, x plus y dy dx equal to 1. Now just see here, if you just consider dy dx, what happens? That will be simply 1 by x plus y, right? So this way it will be very difficult for us to solve, because we know the standard form to be, what is the standard form? Anybody remembers? The standard form was dy by dx equal to dy by dx plus py equal to q, right? So there is no y here. So if you look at the right hand expression, it will be difficult for us to find it. So what we will do instead, just see here what we will do now. Instead, I will do dy dx. I will write first, and which is 1 by x plus y, and then I will transform it to dx dy, which will be x plus y. Okay. Now that the point is, now here we will try to compare to the original format. What was the original format? Dx dy plus, what was that? P1. Now what would you write here? P1x, right? And equal to Q1. So here P1 and Q1 both were functions of y. So we need to write this one in terms of that. So dx dy, then minus, you can write like this, minus 1 x equal to y, correct? Now what would be your P1 here? P1 will be minus 1. What would be your Q1? Q1 will be y. This is your P1, this is your Q1, right? So let's go ahead. Now I will try to find the integrating factor. What is the integrating factor here? It will be integration of e to the power integration of, what is that? Can anybody remember? So that will be P1 dy, correct? So it will be e to the power minus 1 dy. So e power minus y. So that becomes your integrating factor. The next, so let's go ahead. So the original equation was dy dx plus minus 1x equal to y square. So now I will write the general solution. What would be the general solution? The general solution is, you will write x multiply integrating factor is equal to integration of q1 multiplied by if integrating factor dy here, correct? So be careful about this. It was not dx. Previously it was dx. Now it is dy here. So then x integration of integrating factor e power minus y. So what is q1? If you remember q1, so q1 is actually y. So multiplied by integrating factor will be e power minus y. Okay. So that is your dy plus c. Okay. Then go ahead. So this integration you will just write as I plus c. So this is x e power minus y. Okay. Then go ahead. This you can write as 1, and then here you can write where I is equal to how much? This integration, right? Y e power minus y dy, and try to see this here. This is actually your arithmetic function, and that is your exponential function. So if you apply ILET, so which one comes first? A comes first, and then exponents come second. So it is in the order. So we will go ahead. We will integrate it by parts. So y integration of e power minus y dy minus integration of differentiation of y integration of e power minus y dy, and then dy here, right? So you can write y power e power minus y divided by minus 1. Then integration of this one will be 1. That will be e power minus y by minus 1. And then dy, correct? So just you can see here, it's very simple. This integration happens like this, okay? Now, again, we will keep on going. Here, this is minus y e power minus y. So this minus minus will become plus. So this will be e power minus y dy. Okay. So minus y e power minus y, and this integration will give you e power minus y. So now you see we have assumed I to be this function, right? I is equal to this integral. So from 1, now we can replace it. So what is 1? 1 was, if you remember, it was x e power minus y is equal to I plus c. So we'll just simply replace this I, which is this one. This is your I. So minus y e power minus y minus e power minus y plus the constant. So on the left, you can see e power x e power minus y, right? So this I will shift, this e power minus y I will shift towards right hand side, or you can say you are dividing it by e power minus y both sides. Then it will become x minus y. Then it's going to be how much? Minus 1 plus c power y, e power y. So finally, you can transfer this y towards left hand side, and then you will get only c e power y. So that becomes your solution of this. This is the general solution, of course, of the given differential equation. I hope this you understood. So we started from here. Okay. So that is the general solution for this particular equation. All right. So let's go ahead. Then we will take another problem. Let's take question number 12. Okay. Let's take question number 12. One sec. Now take question number 12. So question number 12 is to find the general solution. Again, x plus 3y square, this dy dx is equal to y. Again, for this, you have to find a general solution. Okay, so how would you start? The same way, right? So you will try to find dy dx on the left hand side, and then y divided by x plus 3y square. Okay, so that is your differential equation, given differential equation. Now again, you see here, this again becomes a problem. So you cannot find this particular dy dx in the given format. Say, what was the given format? This was your given format, right? So can you find any comparison between this and this one? Definitely not. So then we will try to write this one as dx by dy, okay? And then we will write x plus 3y square divided by y, okay? Now it looks like something similar to this particular form, dx by dy plus p1x equal to q1, okay? So let's see how we can find it. X by y, this is x by y, plus this will become 3y only, correct? If I'm not wrong, x by y. So that is 3y. Now you need actually this side on the left, you need an x. So definitely this particular thing you can shift towards left side. So I write this one dx by dy. So what you can do, dx by dy, then you write minus 1, and also you can write here minus 1 by y x, correct? And that will be equal to 3y. Now it looks like this particular form, yes? So this will become your p1, that will become q1, correct? So let's go ahead. So p1 I will write here minus 1 by y, and q1 I will write here 3y, okay? Then we need to find the integrating factor. So integrating factor also, this you know that this will be p1 dy, not dx, okay? It will be dy. Now what is p1? Minus 1 by y dy. Fine. So how much will you get? E integration of this is log y. Now this log y you can rewrite as log 1 by y, correct? So finally from here you will get only 1 by y. So your integrating factor finally becomes 1 by y. Okay, so can you tell me what would be your general solution then? Your general solution is x multiplied by if integrating factor, then q1 integrating factor, d, is it dx or dy? Tell me. Definitely dy, right? So just write here, x integrating factor is 1 by y. Integrating factor, what is q1? So you can see here your q1 is 3y, right? So replace that 3y in this one. So write here 3y multiplied by integrating factor, which is 1 by y. So if you multiply, you will get the answer here. Let's see how much you get. Then this is now x by y, and that y get cancelled. So it's going to be 3y plus c. So you see here, your final solution should come in terms of x. Okay, so you write x. So that will become 3y square plus cy. So that becomes your answer. I hope you understood this question. So you can see one more time what you have done. This is the interesting step. From this step to this step, you have to see how you have done it. Okay, because it is not possible to find in this way. So we have changed it, dx by dy. We reversed it. Okay, so that is the way of doing it. Only just you have to remember the form GS. This form, if you remember, and if you can calculate IF, then you are done. Okay, so let's go ahead with another problem now. Let's say Question number 13. Let's do question number 13. Okay. Question number 13. The question says that find a particular solution. Here you need to find a particular solution for dy dx plus, this is interesting question, 2y 10x equal to sine x. And you also have to see that it should satisfying some particular condition will be given here, satisfying y equal to 0 when x equal to pi by 3. So this is a particular condition given, and we need to find the particular solution for this given differential equation. Okay, so you see this particular differential equation you cannot solve by transferring this one towards this side and then try to write y equal to vx. Okay, because it is actually what was your the previous concept of transferring towards right hand side? That was homogeneous differential equation, right? If it is homogeneous, then only you can do so. But here it is not a homogeneous differential equation. Instead, it is a linear differential equation. So we'll try to compare it with the given format. Let's see which format. So dy dx, this one is looking like something like, p. Can you tell me what is that? Py equals to q. It looks like this. But then how will you write this? If you rephrase or rewrite this, then dy dx plus, you will write 2 10x as p and y here, and q will be sine x only. Okay, so now you will write p here as 2 10x and q you will write as sine x. Okay, so you are going to find out what is the integrating factor. The integrating factor will be definitely e power p dx. So e integration p, what is p? This is your p, 2 10x, correct? Now this you have to tell me integration of 10x dx. Prisma, do you remember?
Log of sec x.
Exactly. So I'll just replace it to log sec x. All right. So put a bracket here. So e power log sec s whole square, right? So finally it will look like sec x whole square, correct? So that is your if. Then you need to find your gs. What is the gf? Y into if. This you have to remember at any cost. If then dx plus c. Okay, so now I will replace it. Let me see what is q. Q is here sine x, right? So I'll replace here q sine x. And what is if? That is your sec square x dx. Now if you look like this, it's not going to give you any result. So we will try to put it in a form. So what form? Simple as that. Sine x by cos x we will write, and then 1 by cos x. That you can write sec x itself, no need. Just write sec x here. 1 sec x dx plus c. On the left, of course, this will be y into sec square x. Then keep on doing. This is now 10x, right? 10x sec x dx. So this is same as writing sec x 10x, right? Integration of sec x 10x is how much? Sec x only, if you remember. So that will be sec x plus c. So this side is now y sec square x. So finally, you can write y, if you transfer or shift it towards right, so it will be sec x divided by sec square x is sec x only, and plus c by sec square x, correct? So that will become next cos square x. So one more line you can write, no problem. So y equal to sec x plus c cos square x. That's what you can write. So this is what you got so far as the general solution. Now you have to go for the particular condition. What was the condition given here? Look at the first line. Y equal to 0 when x equal to pi by 3. So we will try to replace it there. Y equal to 0 and x equal to pi by 3. Remember that. So when y equal to 0, x equal to pi by 3. Yes. So this if you give 1, so from 1, y will be 0 and sec x is sec of pi by 3 plus 6 c cos square pi by 3. Now,
When you divide sec x by sec square x, isn't it cos of x?
you mean this?
Yeah, like this should be cos of x plus c cos square x.
No, actually what happened here, no, you are actually dividing both sides. These both sides you are dividing by sec square x. This is what you are doing. Okay. Now this and this if you divide, so that will be 1. You are right, of course, correct. So this should have been not sec x, 1 by sec x, right? 1 by sec x, correct. So in that case, this also has to be cos x then. You are absolutely right. Then the changes also will take place here. You are right. So cos pi by 3. Is it okay now? So this will be half, and see, this will be 1 by 4 because cos pi by 3 is 1 by 2. So now what will be the value of c? So c will be directly if you do, it will be -2, I think. Is it right? Check. That means what I have
Yes,
done.
so it's -2.
Okay, you got it. So actually what we have done, minus half equal to c by 4, right? So next it will be like, minus 4 by 2 equal to c, that is -2. So from 1, we will replace the value y, which is cos x plus c, you will put here -2, and this is cos square x. So just simply rewrite it, cos x minus 2 cos square x. Yeah, so that becomes your answer. So this is again, I'll show you here. This part only, I think sometime you may get confused because you might forget the value of this integration. So if you remember the formula, then you can do only, that is the possibility. And even sometime you might get confused whether to apply this linear differential equation or it is a homogeneous differential equation. So that might be a confusion. So whenever you see here dy dx of this type, then immediately it should come to your mind that it is a linear differential equation. It is always in this particular form. That means this form. Okay, so we will go ahead with another question. Let's do question number 15. All right, question number 15, which is, again, they are asking to find a particular solution. And the differential equation is dy dx minus 3y cot x equal to sine 2x. Sine 2x. And they have given the condition here satisfying y equal to 2 when x equal to pi by 2. So first we will try to find out the general solution, and then we will replace the value of y and x and get the value of constant. And after that, we will find the final general solution. Okay, so let us rewrite this dy dx. So how will you write this? You will write minus 3 cot x, right? And y, and that side sine 2x. So p will be definitely minus 3 cot x and q will be sine 2x. Okay. Then can you tell me the integrating factor here directly? Minus 3 cot x dx. So you are going to get minus 3 cot x dx. So what would be your answer then? Integration of cot x, again that is a problem. So if you remember, that's fine. If not, then so it is log
It's log
sine.
of sine x.
Absolutely right. So you are going to get this, and then in the next phase you will write 3, and then that will become 1 by sine x, right? This will become like, because this minus has gone here, so you can say there is minus 3 also, you can write, no problem. Okay, directly I will write here, no problem. This 3 I will remove, and then it will go up here. Then if you can understand directly, that's fine. And then after the this step, so you are going to get actually 1 by, is it all right? Is it fine? Sine cube x. So remember, this is sine cube x. It's not sine 3x. Huh? These two are different. So it's a power, not 3x. Okay, so then we will try to find a GS. The general solution is, again, that is y into if. If just we got sine cube x is equal to integration of sine 2x, because this is your q. If you remember, this was your q, sine 2x, and then you will multiply it with if, which is 1 by sine cube x dx. Okay, then little calculation will be there. If you do the calculation this side and directly write here, no problem, because there will be some calculation. Sine 2x into 1 by sine cube x. Sine 2x means actually what? 2 sine x cos x. So multiplied by 1 by sine cube x. So one of these sine x will get cancelled. So finally, you are going to get actually what? You will get here 2 cos x by sine square x. Correct. So this again you can rewrite cos x by sine x, and then 1 by sine x. So finally, what would you get? You will get 2 cot x cosec x, or you can say cosec x cot x. Yeah. So this I'm going to replace here. So in this one, I will write 2 cosec x cot x, then dx plus c. Now this 2 will come outside, obviously. And so we write cosec x cot x, because we know this, it is a formula. What formula is this? Integration of cosec x cot x.
It becomes cosec x.
It's actually minus cosec x plus c. Okay. So the left hand side is y by sine cube x. So next we will multiply it. Yeah. So next line will be y. So minus 2 cosec x, sorry, cosec x, multiply it by sine cube x, then next plus c sine cube x. Correct, no? So again, this cosec x and one of the sine will get cancelled here. So from this, what you will get? 2 sine square x. Correct? Then c sine cube x. This is your y. Okay. So that means you got this particular general solution and you are supposed to take the condition which was given. What was the condition given? I think y equal to 2. So you can write when, actually it's not when, y equal to 2 when x equal to pi by 2. This was the condition given. So as this happens, then from 1, from 1 we will write y is 2, this y is 2, then x, this is pi by 2. So directly also you can write sine pi by 2 is how much? 1, right? So 1 square. C sine cube, that is also 1. So finally, this will be 2 minus 2 will be 4, and C only, I think C equal to 4. Is it correct? Check. Is
Yes,
it all
that's
right?
correct.
Okay, fine. So from 1, we will write the final general solution. Y equal to minus 2 sine square x plus 4, C is 4, then sine cube x. So that becomes your general solution after substituting the given condition. So the last part is so easy, there is no problem. Your thing is to find the general solution first. So even if little bit long, no need to worry. Just keep on doing. Don't wait. Keep on doing. You will get the answer. All right. Next, I will take question number 16. All right. Let's see question 16. Question number 16. Is there is a condition given. So let me just share with you just one sec. I will show you which question actually we are doing. Just let me show you 1 second. This is 9.5. I'll show you. Is it visible to you, this which I am showing now, the book?
No, sir.
It's not? Okay, no,
No.
sure. Wait. Question number 16, this. 1 minute, let me show you. I'll show you the question because it has long sentences, so I have to show you the question, then I can do it. Question number 16. Okay. Your screen is paused. Resume share, 1 minute. Okay. Now, can you see this?
Yes, sir.
Okay. So this is the question here. Find the equation of a curve passing through the origin. Origin means definitely it is 0, 0, right? They have not mentioned, but 0, 0. So that point you can take. And given that the slope of the, slope of the tangent. What do you understand by slope of the tangent?
It's y by dy by dx.
Exactly. That means they are saying it is dy by dx. To the curve at any point xy is equal to, that means they are saying dy by dx is equal to, what is that? Sum of the coordinates. Now coordinates are x and y, correct? So sum, if I take the sum, it will be x plus y. So that should be equal. So this is the given condition here. So directly from here, we can do it. So we got this differential equation, and now we will try to see whether we can put it in a particular format. Just 1 sec. So what we will do, dy by dx we write, and then which one would you shift? Tell me, X or Y?
Y.
Okay,
We shift Y to the
Y and then X. So we just, change it like this. We have shifted Y towards left, which is minus Y. So I have written in this form. So P is -1, Q is X. Okay. Then I will try to find the integrating factor. So which is integration of -1 dx. So that is nothing but e power minus x. So now I will find a general solution. So general solution again, y multiplied by if. Every time you don't have to write this, okay? If you remember, directly write the form because I'm writing it to understand now for the time being. Q, if, this is not required to rewrite again and again. Still, I'm writing. So y into, what is if? If is e power minus x. So what is q? That is x. So e power minus x. My internet connection is unstable, it says. Is it working still?
Yes, sir.
Okay, then why they are saying unstable? All right. So now again, you have to think about islet here. Yeah. So this is arithmetic and this is exponential. So arithmetic will come first, exponents second. So I'll take this one as I and then write C here. So y e power minus x. This is now say equation number 1. This is 1. Okay. Then go ahead. Where I is equal to, what is your I? Integration of x e power minus x dx. So this you have to integrate. So x integration of, directly can you do that? Minus x by -1. Then integration of differentiation of the x is 1. Then integration of this will be e power minus x by -1. Then dx. Correct. So then you will write minus x e power minus x. This minus minus will become plus, and this is e power minus x dx. So finally, you will write x e power minus x. This integration is how much? This will be e power minus x by -1, right? So again, you can take here e power, that to minus you can take. This one you can take common, and inside what would you get? X plus 1, correct? So this is your I. Now this you are going to replace here in equation number 1. So this was your equation number 1. So here I will replace. Let's see what happens. So y e power minus x, you can write from 1. The equation was I plus c. So I is minus e power minus x, x plus 1 plus c. And this is y e power minus x. Then I will shift this e power minus x towards right hand side. So you will get y minus x plus 1 plus c e power plus x, right? So that becomes your y. Did you understand this step? Did you understand?
Yes, sir.
Okay. Now we will check the condition, because they were saying what in the beginning they told that it is actually passing through origin. Just check. They were telling that if this particular curve, what you have got is passing through the origin. So 0, 0. So x value is 0 and y value is 0. These two values we are going to substitute. So this is your curve number 2. the curve 2 passes through 0, 0, 0, passes through 0, 0. So you need to write this because they have given this condition, right? So from 2, you will replace this y 0 and x also 0 plus c e power 0. So obviously this is -1, -1, and that is c. E power 0 is 1. So c will be +1, correct? So if you get c equal to 1, then you can replace it in this equation number 2 to get the final solution. So finally you can write from 2 you will write y equal to minus x plus 1 plus c is 1. So simply write this. So that becomes your final answer. Hope you understood this.
Yes, sir.
Okay, and then we go back and see what we have done. So that was actually as what is that called? Word problem. Actually, it's like a word problem. So they have given you some lines, and from these lines you need to derive, okay, and check whether it is falling in the given format or not. If it is in the format, then you can proceed using your IF. Okay, let's see another question. Let's take the final question today, and then I will stop. Okay, this is question number 17, and we will see from here. Is this page visible to you? It's not.
No, sir.
Because it is paused. Okay, no problem. 1 second. Okay, just 1 second, 1 second. Now, is it sharing? Can you see the question here? Is it
Yes,
shared?
sir.
Okay. So we see this question. Yeah. Find the equation of a curve. So again, the same way, you need to find the equation of a curve passing through the point. This time they have given the point 0, 2. Given that the sum of the coordinates, so these are the two coordinates, right? They are saying that sum of these two coordinates, which is 2, 0 plus 2 is 2, of any point on the curve exceeds the magnitude of the slope of the tangent. That means what actually is happening, there is a curve and there is actually one tangent, and this is touching at 0, 2, say. Okay, and they are saying that this condition they have given, that the sum of the coordinates of any point, if this is the point P, if I say this is the point P, this may not be the 0, 2, it may be somewhere here also, but if I take a point P, this point should satisfy this condition. Coordinates of any point on the curve exceeds the magnitude of the slope of the tangent. So we know the slope, that is dy by dx, and they are saying it exceeds by how much? By 5. So the dy dx, in fact, sum of this, I will redraw it, okay, because it will confuse you. Say I draw this way. Say this is a point P now, which is say xy, okay, and this is the curve. It may be say passing through this 0, 2, 0, 2, okay, 0, 2, somewhere here, somewhere here. So now we will try to find the dy dx at this point. And then they are also giving the condition that the coordinates, these two coordinates, their sum is actually greater than the slope by 5. So from this, what we understand, if I take the sum of these two coordinates, say P is the point, okay, then we take x plus y, it must be definitely greater than dy dx, correct? And then if you see how much it is greater or how much it exceeds by 5. That means if it is equal, then you have to add 5 on the right. Then this will be equal. So this x plus y is greater than dy dx by 5. This is what it means. Greater than dy dx by 5. Then only it will be equal. Okay. So we got this differential equation. So I will write dy dx as, sorry, dy dx as, then again, this we will try to see in that format, dy dx plus py equal to q. So you need a y on the left. So obviously, this y you have to shift. This one you have to shift. So this will be minus 1 y. And the x part will be on the right. So x minus pi will be on the right hand side. So this is your q, this is your p, correct? So we write p equal to minus 1, q equals x minus 5. Then we find if, which is integration of minus 1 dx. So how much is that? E power minus x. So e power minus x becomes your integrating factor. So then we will go for the general solution. What is the general solution again? Y into integrating factor minus this one. Directly you can write as I told you. Then q is x minus 5 and multiply it by e power minus x dx plus c. Okay. So next you will try to integrate. So again, this you can integrate here itself, but it will be long. So better to write it like I plus c, which is 1. Okay. So your I is where I is equal to integration of. Now again you will use eyelet. Yeah. Eyelet. So if you look into this particular thing, this x minus 5 is your arithmetic function and this is your exponential function. So arithmetic comes first, exponent comes second. So it is in the order. So I will write x minus 5 integration of what is that? E power minus x, right? So minus x dx. So I will try to integrate it now. The same way, I will use this one as you can see, this is your u and this is your v. U, v function. So first you will use x minus 5, that is u. Integration of this directly I will write e power minus x by minus 1 minus integration of differentiation of the first, that is differentiation of x minus 5 will be 1, right? And integration of the second, that is e power minus x by minus 1 dx. So it looks like x minus 5 e power minus x. This minus minus becomes plus. So e power minus x dx. Okay, then go ahead. So minus x minus 5 e power minus x, and then again this will be e power minus x. So we can take e power minus x as common and that to minus. So x minus 5 plus 1, right? Then it will be 4 minus 4. So minus x minus 4. So on the left you had okay, this is the integration. Actually, there is no left hand side here. So this is your I. This is your I. So we will replace this I in equation number 1. This I we will replace here in this equation, which is say 1. Okay. So now we will do it here. Y from 1. From 1. So y e power minus x is I plus c. I'm writing again. So y e power minus x equal to minus e power minus x minus 4 plus c. Okay. Then you can just simplify more. This will be y equal to minus x minus 4 plus c e power plus x. Okay, so you got this particular general solution. Now they have given you a condition that it passes through this particular differential equation will, or this curve, that is actually a curve. This curve is passing through 0, 2. So x is 0, y is 2. So replace here. It passes through, you can write, it passes through 0, 2. So you write this equation as number 2. So from 2, from 2, you will write x value is 0. Sorry, this is 2, y is 2. So x is 0 plus c e power 0. X is 0, no? So finally 2 equal to 4 plus c. So that means c will be minus 2 here. Correct, no? C will be minus 2. Is it right? See?
Yes, sir.
Okay. So now we will replace this C here and we will find the final solution. So I will write here. So from 2, you will finally find y equal to minus, you can open this bracket if you want, no problem. Then minus 2 e power x. So if you really want to make a change, you can do like this. Minus 4 equal to minus 2 e power plus x. Is it done? This I have shifted towards left, so it becomes like this. And final solution is this. Is it done?
Yes, sir.
Okay, so today I wind up here, and in the next class I will try to explain on vectors. Okay, today we have done these many questions, so you can see from where we started, and we started from question number 13, we completed this, and then we done question number 15, and then question 16, and then question number 17 just now. So I have recorded this session, hopefully. Let's see if it is working or not. I don't know. Hopefully it should work. So thank you, all of you, those who have joined. I think only Prisma has joined, but all the other students should also watch this. Thank you all.